Now we consider the PDE of first order. PDE, first order PDE. Now we consider the first order PDE. We know what is first order, the order of a PDE, order of the highest order partial derivative. So the first order PDE with a one dependent variable. Here the Z is a dependent variable. Only one dependent variable and most of two independent variables. X and Y are the two independent variables. Z be a dependent variable and X and Y are the two independent variables. Then here del Z by del X is usually denoted by P, small p. Del Z by del X is denoted by small p. Del Z by del Y is denoted by small q. Del Z by del X is small p and del Z by del Y is small q. Come to the second order partial derivatives. There is del square Z by del X square. This is usually denoted by R, small letter R. Del square Z by del X square. And what is S? S is del square Z by del X del Y. And T is represented by del square Z by del Y square. So these are the usual representation for a first order partial differential equation having one dependent variable Z and most of two independent variables X and Y. So these are our representation. P is del Z by del X, Q is del Z by del Y, and what is R? R is del square Z by del X square, S is del square Z by del X del Y, and T is del square Z by del Y square. So by using the first order partial differential equation, then the first order PDE is of the form of X, Y, Z, P, Q equals 0. These are second order partial derivatives. So the first order partial derivatives. First order partial derivatives is of the form first order partial differential equation or partial derivatives. First order partial differential equation is of the form f of x, y, z, p, q equals 0, where p is del z by del x and q is del z by del y. Z be the dependent variable and x and y are two independent variables. So this is our usual representation. The first order partial differential equation may be represented by f of x, y, z, p, q equals 0. Okay. So now you consider an example. From the PDE of the surface of the form f of uv equals 0. F of uv equals 0. So what is u? U is a function in x, y, z. U equals u x, y, z. And what is v? V equals v x, y, z. U equals u x, y, z. V equals v x, y, z are non-forms of x, y and z. Then how to form a PDE corresponding to this one? So for that, it is given f of u equals 0 where u and v are in terms of x, y and z. Okay. Then you can derive partially with respect to x and to y. What is it? When you differentiate this partially with respect to x, so it is del f by del u into del f by del u of into it is del u by del x. With respect to x, x is an independent variable, del u by del x plus here y is again an independent variable, so del y by del x, del u by del x, del u by del y is another independent variable. Z is a dependent variable that mostly depends upon this both x and y. So it is del u by del f by del u into, and but u is a function in both x, y and z. X and y are independent and z is a dependent variable that mostly depends upon this x and y. So if you partially derive this f of uv equals 0 by with these restrictions, then it gives del f by del u into del u by del x plus it is del u by del z del u by del z into del z by del x equals 0. Or sorry, plus equals 0 plus del f by del v. Del f by del v into same arguments del u by del f by del v into del v by del x plus it is del v by del z into del z by del x equals 0. Okay. Similarly, if you derive this equation 1, partially derive with respect to y, what I get? Again it is del f by del u into it is del u by del y plus del u by del z into del u by del z into del z by del y plus del f by del v into it is del v by del y plus del v by del z into del z by del y equals 0. So here x and y are two independent variables. There is a dependent variables. There is a dependent variable that depends upon x and y. F of u v equals 0, where u and v are the functions of x, y, and z. After taking the partial derivative of this f of u v equals 0 with respect to x and y, we have these two equations. Okay. Then you can eliminate this del f by del u and this del f by del v. You can eliminate this del f by del u and del f by del v from these two equations. How? So takes there, that means it is ux. Del u by del x is represented by ux plus determinant del u by del z, uz, del z by del x. We know del z by del x is small p. Again, del v by del x, that is vx plus vz into del z by del x. So del z by del x is again p. Del u by del y, that is uy plus del u by del z, uz into del z by del y is q. Here it is vy plus vz into q, determinant. This, if you eliminate this one, then you have this determinant should be 0. If you eliminate, you can multiply these two by some terms and subtracting, then finally you have this determinant. Okay. So that is ux plus uzp into vy plus vzp minus of this one into this one should be 0. After, if you are opening this determinant, then you have that result. So that means ux plus uzp into vy plus vzq minus uy plus uzq into vx plus vzp equals 0. That is finally, that means if you opening this determinant, it is small p into uz into vy, uz into vy minus uy into vz plus q into ux vz minus uz vx plus there is a term which is independent of this p and q, that is ux vy minus uy vx equals 0. Okay. If you open it, ux plus p into this one, that is ux vy, that's the term. uzp vzq. Okay, again ux into vzq, that is q outside, ux vz, this one, and so on. If you operate this determinant, then and you can associate the terms which involves p and q, then and the third term is strictly independent of both of this p and q. Okay. Suppose this is capital P. This term is the term in this bracket is referred as some capital P. So that equation becomes small p, capital P into small p plus. Suppose this is referred as some capital Q. So it is capital Q into small q equals some R. Suppose this is R. This is a capital Q, this is a capital P, and this is capital R. So it is PP plus QQ equals R. So which is called Lagrange. This is called Lagrange's partial differential equation. This is called Lagrange's partial differential equation. Lagrange's partial differential equation. So the Lagrange's partial differential equation is of the form PP plus QQ equals R, where capital P, capital Q, capital R is defined as in this way. Small p is del z by del x and small q is del z by del y. So by using the usual notations, we derive this Lagrange's partial differential by using this argument. If f of u equals 0, where u and v are the functions in x, y and z, first we differentiate this with respect to x, and again differentiate with respect to y. X and y are independent variables, z is a dependent variable. Then after eliminating this del f by del u and del f by del v, we have this determinant. If you opening that determinant, then you have these three terms. The one is in P, other is in Q, and third one is independent of this P and Q. Then if you refer to this as capital P, capital Q and capital R, then that is comprised as PP plus QQ equals R, which is called Lagrange's partial differential equation. So actually, what about this capital P? This is u z Vy minus what is capital P there? Capital P. Listen, what is capital P there? Capital P is capital P. This one, u z Vy minus uy vz. That is del u by del z into del v by del y minus del u by del y into del v by del z. Okay, that is the Jacobian of uv by Jacobian of del uv by del z. This is P. That is the Jacobian. P is the Jacobian. The del uv by del xy. That is ux vy minus vx uy. That is this one. That's this Jacobian. Here this P is del uv by del zy. Okay, and what is Q? Similarly, this Q is again del uv by, this is Q, del uv by del zx. This is Q. Okay, and what is the right side arm? R is the Jacobian, that is del uv by del xy. So this is P, Q and R. Capital P, capital Q and capital R is referred as in this way. Okay, so then you will remember this Lagrange's partial differential equations, that is from f of u equals 0, where u is ux, y, z, v is vx, y, z, where x, y, z, x, y are independent variables, z is a dependent variable. And after taking the partial derivative of this f with respect to x and y, and you can eliminate this del f by del u and del f by del v. There is a determinant. If you opening the determinant and rearrange, it is in this way, and you renamed this as capital Q, capital P and capital R, where P, Q and R are given here, then PP plus QQ equals R, which is called the Lagrange's partial differential equation. Okay, thank you.